Hi everybody, and welcome to the second video on functions. In this video we simply continue what we started in the first video. We continue our study of functions, and in particular there are four things that I want to do for you. I want to show you four different examples of functions in the hopes that this will make you feel more comfortable with them. So functions are like arrays or like vectors or like loops. Any of these concepts take getting used to. You simply must work with them for a while before you are used to them. So this video is an effort to help get you more comfortable with these things, and I'm going to show you four different examples. The first example will be the bonus question from your first exam. I'll show you how to use a function to do that. The second example will be to write our own find function for strings, because the find function that's built in is not working like we thought it would. The third thing that we will do is we'll write a function that replaces every instance of bad with good and worst with best inside of a string. So a function that makes strings more positive, I guess. And then we will close by looking at a particular kind of function called a void function. So let me just refresh your memory. Here is the bonus question from exam 1. The user enters an n value, and the program prints all of the prime numbers between 2 and that value. So if the user enters 12, the program should print all prime numbers between 2 and 12, and here they are. So let me just remind you that prime number is not necessarily an odd number. Those concepts aren't the same. A prime number is a number whose only divisors are 1 and itself. So 5, 7, 11, 2, 3 all have that property, but think about 4. 4 has a divisor of 2. Right, so 4 is not prime. So here's a schematic of what you can do to write a program like that. Essentially, you just want to start at 2 and then just march number by number, one by one, up to the number the user gave you. If the I value that you're at currently is prime, then go ahead and print it. But if the number you're currently at is not prime, then don't print it. So here's just a schematic of what you should do. Just check number by number whether or not that number is prime. And if it is, you should print it. Now of course, C++ doesn't recognize this. If you type this in, it won't know what you mean. You have to teach the computer how to check whether or not I is prime, and several of you were successful at this in your exam. One of you actually wrote this exact thing right here. So you understood the general schematic, but forgot how to check whether or not a number is prime. So I want to use a function to check whether or not this I number is prime right here. Because one of the things that functions allow you to do is take a task that consists of lots of little subtasks and separate out the subtasks. So here I have sort of a global task, which is to just march number by number, and then inside of that I want to check if a given number is prime. So let's just take that prime checking subroutine out and put it somewhere else. It allows us to sort of take a bigger problem and break it down into its component problems. So I'm going to go to my compiler here in a second and just write a function that does this. It checks whether or not a given number is prime. So in my compiler now, let me get a number from the user. And now let me just write this schematic that I have on the slide. I'm going to start at 2. I'm going to go up until that number. And if the I value that I'm at is prime, then I want to see out that number, print it to the screen with some spaces in between. Okay, but of course C++ doesn't know what this means. So let me just write a function, and it will be a Boolean function. I'm going to call it isPrime, and what this function will do is it will take a number and decide whether or not that number is prime. If the number is prime, the function will return a true value. But if the number is not prime, the function will return a false value. So in terms of that language here, let me rewrite this. I'm going to feed each I value into the function. And if I get a true value back, that means the number is prime. So I would want to print it. But if I get a false value back, that means that the number was not prime. So I won't print it. So in English here, what I've done now is I've taken a subtask, a subroutine, and I'm going to break it down into a separate function. So that here, this for loop in main is just going number by number from 2 up until n, and then I'm just asking about each individual number, is that number prime or not? If it is, then print it. But if it's not, then don't print it. So now let me actually define this function that checks whether or not the input is prime. Okay, so what I want here is, we've done this a couple of times now, but let me just do it again. This is the code that will check whether or not a given number is prime. I'm just going to start at 2. I'm going to go up until a minus 1. Okay, what do I want this for loop to do? I want it to check whether or not a has any divisors. If a has any divisors at all that are between 1 and a, right? So maybe 2 divides a, or 3 divides a, or whatever. If a has a single divisor that is not 1 or itself, the function should return false. Because if you have any divisors at all that are not 1 or yourself, you are not prime. So now here let me just check. If a is a multiple of I, or if you like, I is a divisor of a, what should happen? I should return a value of false. Okay, so what is this for loop going to do? It's just going to march number by number, starting at 2 up until a minus 1, and check if any of those numbers are divisors of a. And if you find a single divisor, then you will enter this if statement and you will return false, and the function and this loop will just stop. Okay, so I've mentioned this before, but keep this in mind. As soon as a function encounters a return statement, the function stops. So therefore this for loop will also stop. But suppose you don't find any divisors, so you never once enter this if statement. Well, if that's the case, then you must have found no divisors, and you would want to return a value of true. So you do this for loop, you check for divisors. If you never encounter this return statement, that means that your number must be prime because you found no divisors. So we will return a value of true. And now let's just run this program. So now I have my for loop up here in main that marches number by number and checks whether or not each number is prime. And inside I'm going to feed each I value into the function that checks whether or not it's prime. So let's just run this and see. Let's enter like 18. Okay, and there you go. It prints out all the prime numbers between 2 and 18. Okay, so I wanted to show this example to you for a few reasons, but the primary reason is that I want you to see that functions allow you to streamline your thinking, and they allow you to break a complicated problem into smaller subproblems. So if you wanted to do this overall problem, right, printing the prime numbers between 2 and n, that requires two things. It requires you to march number by number, starting at 2 up until n, but it also requires you to check whether or not each of those numbers is prime. So if you try to write code that does both of those things at the same time in main, you are inviting error. Okay, when you try to do too many things at once, you're just asking to make mistakes. Now several of you were able to do this on your exam, and that's fine. But here what I've done is I've taken the marching number by number task and the checking if something is prime task, and I've separated them out so that checking if something is prime is done elsewhere. So now that we have this task done elsewhere, the overall program is just built from main and this separate function. So again, using functions allows you to take something complicated, break it down into smaller parts, and then the overall program is built from these smaller parts. So it lets you streamline your thinking, it lets you separate subproblems out into their own sort of separate thing, and so it lets you see things better. It lets you just sort of segment things out, and it helps organize your thoughts better. Okay, so now let's go back to our examples. The next thing I want to do is write our own string find function. So remember how string find is supposed to work. There's a built-in function whose syntax is .find. You hand it the position where you want it to start looking, and you tell it what you want it to look for. The function returns the first position of this substring inside of the global string that it finds. And if you tell it 3 right here, it starts looking at position 3. What is supposed to happen is if the computer doesn't find another string, the computer should give you back -1. This has not been the case for us, and I still don't know why this isn't the case. So several of you get answers of like 400 million or something when the computer doesn't find what it's looking for. So I don't know why it's doing that. I have not been able to figure that out. So I thought, screw it, let's just write our own function that does what it's supposed to do. So let's write our own function that searches a global string for a substring and returns -1 if it doesn't find anything. So here's what the declaration of the function will look like. This function returns an integer because it returns either a position value or a -1 if it doesn't find anything. We have to give this function 3 parameters. We have to tell the function what position we want it to start from, so like this 3. We also have to tell it the string that we're looking inside of, so what's the global string. And then we have to tell it what it's looking for. So we're going to tell the computer, you're going to give me a number back. I'm going to hand you a number that represents a position. I'm going to give you a global string, and I'm going to give you something to look for inside of that global string. So let's just go back over here to the compiler and let me declare the function up here. So it's an integer return function. I'm going to call this function string find. I have to give it a position to start looking from, a string inside of which it will look, and a substring that it's going to look for. So here's the function declaration, and now let me go down here and actually write the thing. Okay, so how does this work? Well, what we want to start doing is we just want to go through the string and look position by position for substring. So we're going to start at position 0 and just ask, do I see substring at position 0? And if I do, I'm going to return a 0. If we don't see substring at position 0, we move on. Now we are at position 1 and we say, do I see substring here? And if so, we return that position. If otherwise, we keep going. Okay, so to make this more precise, we want to start looking. So I here is the position inside the string. We want to start looking at the position the user gave us to start looking at. We want to go until we reach the end of the global string. And we just want to go one character at a time. Okay, so what's going to happen here? This is going to look kind of complicated, so let me just write it out and then we'll talk about it in a second. So if I see the substring at position I, and so remember this substring function, what we have to do is we have to tell it where we want it to look, and we want it to look at position I because that's where we're at. We also have to tell it the length of substring we're looking for. Well, if we're looking for this substring guy, then if we're at position I, we want to look for a substring of that length. And then we just want to ask, is the thing that I see equal to substring or not? If we see substring, then we return the position we're at. Okay, so let's talk through this. This for loop starts at the place inside of the string that the user gives you, right? I want to start looking at position 4, let's say. So this number right here is 4. So I'm going to start at 4, and I'm going to keep looking until I get to the end of this global string. Now I'm going to march just character by character. Now wherever I am inside of full string, I want to look at the substring length at that spot. So let's just say, for example, this substring is the word worst. Well, worst has length 5. So right here, what I'm saying is, inside of full string, I'm looking at a given position for a substring of length 5, and I'm asking whether or not that substring equals worst. So I'm just comparing the substring I'm at right now, the substring at position I. I'm just comparing that to the substring I'm looking for. If I find what I'm looking for, then I want to return that position. If I never find what I'm looking for, that means that I never entered this if statement, so I never found what I'm looking for. So I'm going to return a -1. So let's just see if this works. So let's get a string from the user, and since it might be a phrase or whatever, let's use getLine. And okay, now let's search. Let's decide what to search for. Let's search for bad maybe, whatever. Okay, so now let's see out. What's the syntax here? String find. Now I have to tell it where I want it to start looking. So let's start looking at the beginning. Why not? The full string that I'm handing, the string I want to look inside, is X, the thing I got from the user. And let's also hand it this substring. Okay, so what's going to happen here is I'm going to get a string from the user, and I'm going to look for the substring bad inside of that string. And I'm telling the computer to start looking at position 0. So let's see if this does what we think it should. So let's just type like good, bad, high, and whatever. It outputted 5. So 0, 1, 2, 3, 4, 5. Okay, good. It outputted what we thought it should. It gave me the first instance of the word bad. So let's just try again. Good, bad, bad, high. It did the same thing. It gave me the first instance of the word bad. Good, high. It gave me -1. It didn't find a bad. So this function that we've now built together does what the original find function was supposed to do. It returns a -1 if you don't find what you're looking for. Okay, so here's what that looks like. So you just search position by position, and the first time you find something, you return that position. If you never find anything, you return a -1. Okay, let's now go back to our examples. The next example is to write a function that takes a string and changes all instances of bad to good and worst to best. So we're going to take a string that's maybe negative and make it more optimistic. So what does that look like? Well, this function is going to return a string. It's going to take in a string and give you a string back. So make positive is the name. I'm just going to take a string in, and I'm going to return another string. So let's make that function up here. So wherever, okay, so string make positive, and I have to feed a string into it. And now let's create it down here. Okay, so what does this look like? Well, let's create a copy of the string first. So what I'm going to do is new string is now whatever A is. It's whatever string you feed in. So A right now maybe has bads and worsts in it. So I'm going to start by making a copy of that, and then I'm just going to tweak new string so that all instances of bad are now good and all instances of worst are now best. And then I'm going to return new string at the bottom. So I have to fill this in, but new string is the string I'm going to create that starts with A, and then I make new string the positive version of A. Okay, so how am I going to do this? Well, first of all, I need to find all instances of bad and replace them. So let me just start by letting x equal string find. And what I want to do is I want to start looking at the beginning, and I'm going to look for bad, and I'm looking inside the string. What, new string? Oh, sorry, I have to tell it the global string first. That's the way I set it up. String bad. So notice that I'm actually using the string find function we just made, right? Because that's what I want to do. I want to find the first instance of the word bad, and of course what I want to do is I want to replace it with the word good. But furthermore, if there are multiple instances of bad, I want to find all of them, and replace all of them. So let me write a loop like this. As long as x is not equal to -1, what do I want to do? I want to do new string dot erase at whatever position I found, and I want to erase something of length 3. Okay, so suppose that I found a bad. Right? If I find a bad, I want to erase the substring of length 3 at that spot to get rid of that bad. And then what I want to do is I want to insert at that spot the word good. So I'm just replacing bad with good. And then I want to keep going. I now want to find x equals string find. I now want to start looking at x. Bad. And actually I can just, it doesn't matter, but I can actually just have a 0 right here because I've taken care of the first instance of bad. So right here I find the first instance of bad, I get rid of it, and now I just ask, okay, is there another instance? So I update the value of x to find the next value. And now what I can do is I can declare a new variable y that's going to find the instances of worst. So I'm going to start looking at the beginning. Okay, so x was a variable that tried to find instances of bad and then keep looking. Y is going to look for instances of worst and keep looking. But the loop I'm going to set up is the same structure here, right? I'm just going to, if I find the word worst, then I'm going to erase it at the position where I found it. I'm going to now insert the word, oops, keep doing that, the word best, and I'm going to now search again. So after all of this, now when I return new string, what's happened? New string now, I've taken the original string A and I've replaced all instances of bad with good and all instances of worst with best. Okay, so again, if anything is confusing here, let's just talk through what happens. A is the original string you feed in. I started by making a copy of it, and I'm going to mess with that copy. The first thing I did was I looked for the instance of bad, and I looked for it using the string find function that we just wrote. I looked for it starting at the beginning because I want to find any instances of bad. If I find such an instance, then I now enter this loop, I erase the instance I found, I replace it with good, and now I just ask it to look again. And as long as it looks and it finds something, I keep doing this. And now I move on, I let y be the first instance of the word worst, and if I find such a thing, I erase it and insert best, and then look again. And as long as I keep looking, and as long as I keep finding, then I will keep erasing and inserting. And once I'm done with both tasks, I will return new string. So let me come back up here again. I'm still going to get a string from a user, and now I'm going to have new string equals make positive x, and then I'll cout x. Oops, sorry, cout new string. Okay, so what is going to happen here? I'm going to get a string from the user. I'm going to create a new string that's simply the positive version of that string I got from the user, and then output the positive version. So let's see if this works. Okay, this is bad, this is the worst, this is bad. Okay, so what should happen here is this now becomes x, x gets fed into make positive, and then new string is the positive version, so what should pop out is good, best, good, I guess. Okay, good. It worked. Okay, good. I'm always slightly surprised when my code works the first time. Okay, so good. I feel real good about myself that worked on the first try. Okay, so again, what happened was x gets fed into this function, so now x is playing the role of a. Okay, so a is just a catch-all name for whatever gets fed in. So x gets fed in, so the first thing that happens down here is new string becomes x, and then it goes as we said. Okay, so at this point, I don't remember if I pointed this out or not, but one thing to notice is that once a function is done running, every single variable that was created inside that function is killed. So new string here is killed, x is killed, y is killed, and I guess that's it. All right? So it's kind of like a for loop, where if you create something inside of a for loop, once the for loop is done, the variables that you declared there, like the I, it's now done. That's why you can have a new string up here in main and a new string down here in make positive. In general, you can't have multiple variables with the same name. But you actually don't in this case, because this new string lives up here in main. This new string down here lives in make positive. So they never like interact with each other. This new string is only created when the function runs, and then it's killed when the function stops running. Okay, let me now show you our final example here, a void function. Void functions don't give you anything back. So generally void functions are used to like print things to the screen, because if all you want done is printing to the screen, you don't have to return an integer value or anything for that. So let's now write a void function to print a 2x2 array. And so let me just bring up, where is this? Okay. This is the example that I started with. Oops. I didn't actually copy it. Here we go. This is the example I started with at the beginning of the last video. This is a program that the user enters an array and you do all sorts of things with it. You print out the array they gave you, then you compute the transpose and print it, you swap the rows, you swap the columns, etc. Right? And so multiple times throughout this code, you're printing a 2x2 array. So let's now just write a function that prints a 2x2 array and doesn't return anything. The way you declare such a thing is like this, so void print array, and then you're done declaring. So void basically just means, look, it's going to run, but it's not going to give you any output back. It might do things like print to the screen, but it's not going to have a return statement that gives you something back. And what am I going to feed into this function? Well, if I wanted to print a 2x2 array, I have to feed in a 2x2 array. So I'm going to feed in a 2x2 array, and all that this function is going to do is print it. So let me just go down here to the end. If you want to print a 2x2 array, you simply, where's the original for loop I wrote? Okay, there's the code that prints a 2x2 array, if it's called array. So I'm going to feed in an array, and the name can be whatever I want, but all that's going to happen is whatever array you feed into it, it's just going to print it. So let me now come back up here into my code, and okay, where is it? Here's the first instance of printing a 2x2 array. So let me just, oops, array, and now I'm going to give it array is what I called it. Here's the next instance of a print. So now let me just print array. Transpose is now the array I wanted to print. And here's the next instance of a print. And this array here is called rows swapped because I swapped the rows. Let me now print that. And finally, there was one more print command down here. And this array is columns swapped because I swapped the columns. Now let me just print that. Okay. So notice this code now is much nicer. It's much more streamlined. Okay, you don't have the same stupid code over and over again where you're saying, look, here's a new array, please print it for me, right? Here's another array, please print it for me. That single task has now been outsourced to a single function. So you don't have to copy and paste the same code all the time. I mean, I guess you have to copy and paste this little tiny print array command, right? But this is much nicer. The code is much cleaner now. So let's now just run this and make sure it works. So 1, 2, 3, 4, and notice it still prints all the different arrays that it was supposed to. Here's what you entered. It gives me the original array, the transpose, rows swapped, and columns swapped. Okay, so notice here in this void function, I didn't return anything. There's no like, oh, and return like -1 or whatever. Void means you don't need a statement like that. So void functions a lot of times are used for printing things. If you want a separate function to print like a 2x2 array, or maybe to print a vector, things like this, you can just write a void function. We're going to use them in other ways as we move through the material, in particular when we talk about passing by reference, which we'll get to in maybe 2 or 3 class periods. We will use void functions for that as well. Okay, but for now, that's all I have to say about functions in this video.